Hi, welcome to this program tutorial on C#, some of the basic cool features of the language. In this video we are going to cover the implicit type declaration, that's the new var keyword, then the new object initializer syntax, then extension methods, lambda expressions, and a bit of LINQ using the extension methods and lambda expressions. So this is not exactly a starter course, so before going into this you should probably have some experience on programming in C#, and you better comfortable or at least aware of the concepts of generics and delegates. Don't need to be in great details though, so we'll have some brush up on those in this course, but it's good to have used them before. And finally, a willingness to learn and code better, so that you'll save some time for yourself at work and you can spend time thinking about your designs and other stuff than just figuring out how to implement things. Okay, so the first feature we are going to use in this tutorials is the implicit type declaration, which is new in C#. So earlier when you declare a variable, you would type out the all the lengthy type names and the variable name and then new it. Okay, so Microsoft had saved us a lot of work on that, and now you can just say var customer equal to new whatever type it is. So the compiler is going to infer the type of this variable based on the type of object you are assigning it to. So obviously this puts one restriction, that whenever you use var for declaring, so that variable has to be initialized whenever it is declared. Okay, so you just can't say var customer semicolon and go ahead. No, that's not possible, because the compiler is not going to know basically what type you might assign it later on, and it's not it wouldn't be exactly type safe. So you have to initialize it there and there, but it will save a lot of typing to you when you think about all the coding you do throughout the day. Alright, the next feature is the new object initializer syntax. The name is a bit lengthier, but what it basically means is whenever you are creating an instance of an object, you can pass the values for all the public properties inside that class. Okay, so here is how you do it. So you say var customer new customer, and instead of those starting bracket and ending bracket and having a customer or a constructor inside this customer class which will take these parameters and then have your fields assigned to those parameters, you don't need to do anything like that now. So you just start with curly brace, and the Visual Studio IntelliSense will also help you with the public property names, which you can directly initialize here, as you can see. Okay, so we are going to make use of this feature as well in this course. Now for other features like extension methods, lambda expressions, LINQ queries, what we'll do is we'll just actually go into the code and just get familiarized with what objects we're going to play with and what we're going to do with them and what exactly we're trying to do. So we'll move back and forth between this presentation and Visual Studio to get the concept and then go to the implementation. So we're basically going to see 6 different ways in which we can achieve one particular operation. Okay. So this is a sample code which we're going to use here. So it's a console application, as you can see. And inside this main method we have those 6 different methods of operations. So what we're going to do basically is we'll have a customers list. If you're not aware, list is basically a generic type. Okay, so that gives us a lot of functionality on dealing with this collection. So we'll have a list of customers ready, and we'll have 6 different methods to pull a desired list of customers out of these. Now this get customer and this customer type, they are defined here below. So the customer type is a simple type with just 3 public properties, name, age and city, and also overridden the toString method to conveniently display the customer details just by saying customer.toString. Okay. The get customer method is again a simple method. It just uses the new object initializer syntax and creates new customers. Again, you can see here how you can initialize the collection as well using the same object initializer syntax. Even if you have another complex type inside this, again you can nest it using these curly braces basically. Okay, so this is going to give us a list of customers populated already, and I have some methods here. So one is display customers based on these operations. We are going to give them the customer list we have pulled out by that operation, and that will be just displayed to the console so that we can compare it later on. It just displays this list out of this customer list, nothing else. So here again you can see the use of var keyword. So in Visual Studio, if you just hover over this var, you can see the type. So it's test_link.customer, which is basically what the type is. So inside this namespace, and this is the type we're using. Alright, so this is again a simple method, and we have another method here, is customer old enough. So this is a static method which takes customer as a parameter, and this is going to check if the customer's age is greater than 30. If yes, it will return true, otherwise it will return false. So in our course of programming, we'll make use of this method, passing customer to it and getting a boolean value whether it's old enough or he or she is old enough, right? Okay, now let's jump in to the first method. So just before all these things we discussed, how we would have done this. So we already have a list of customers here, which will be 4 customers as we saw, and we now want a desired customers list. So we just new up a list of customers, then we would have iterated to this customer, right? And if we would have checked using this method we just saw, right, passing that customer object to it. So if it returns true, that means the customer is old enough, and then we'll add that customer to this desired customer list. Sounds good, right? And then we'll print out that list to the console. So let's just run it and see if it actually works the way we are thinking. Okay, so I'll just step over this code. Okay, so if you go to the console, we have an output. So before all this, so these 2 customers are there in this list, and the age of both these customers is greater than 30, 32 and 36. That's how they have appeared in this list. So it seems to be working fine. So if we come back here, we can see basically these 4 customers, and you can see the customers name, ages and cities here. So 26, 36, 32, 29. So basically these 2 customers made it to the list. Now this is, you can see this details at the object level because we have overridden the toString method. Okay, so this is another just a little trick which will be very helpful for you in debugging as well. So whenever you create a new class, it's helpful to override the toString method if it is a complex type and you might want to see what that object contains just by looking at the the object level. Okay, so this desired customer list turned out to be the way we wanted it, and this logic works. Now we want to see if you can make use of extension methods to achieve the same functionality. So just go back, we'll go back to the presentation once and see what exactly extension methods are. So extension methods are basically methods added to an already defined type. So in our case, the customer is an already defined type. We want to add a method to it that will become his extension method. So we are kind of extending that type to add this behavior, but it's not exactly by modifying that class. So we'll see how it works. So just to think of it, say, have you ever wanted that the string class in .NET Framework had this method called isLength less than 10, for example, and now you can have it. So you just need to create a static method inside a static non-generic class, and the first parameter of that method has to be the type on which you want to add this extension method to. So we want to add this extension method to string, for example. So this will be the first parameter, and it has to be preceded with this keyword. That's all you have to do. Now whatever logic you want to write, you can write it here. So in this case, because we wanted the string length to be less than 10 compared, so we'll return the boolean result of this comparison. And once you have this method in scope of your code, you can just call this method on any string. So a string dot, and the IntelliSense in Visual Studio will also show you this method everywhere. Alright, so it won't take any parameters there, because this first parameter over here is for compiler to know on which type you are adding this method to. So in case you wanted more parameters, you can just place comma here and go on adding those parameters. So those will become actual parameters to this method, this extension method, when you will use it. Okay, now the last point is it just basically compile a trick, obviously, because you are not modifying the type on which you are adding a method. So what compiler is going to do is the compiler is going to generate a code so that it will call this method, okay, and pass your object to this method and rest of the parameters, obviously, get this result and put it back on the same line where you have this interpretation that you are calling the method on the same object. Okay, now just go back and see if we can actually write an extension method for our customer class. Okay, we are back here, and let's target this. So we have a method where we are passing customer just to know that if the customer is old enough. Well, speaking of object-oriented feature, wouldn't it be nice if the customer knows for himself, because the customer object already knows his age, so he will be able to tell us if he's old enough. Okay, now the definition of old enough might probably has to be told by us what exactly we mean by old. So I have an extension method written here for customer, and here it is. So it's defined on a static non-generic class, that's the requirement, and we have a static method, it's called isOldEnough, and the first parameter, this customer. Fine, and this is another parameter I have added. So actual method is going to have this parameter. Let's see what we do here. Pretty simple, right? So this customer's age we compare with this age and return true or false. Sounds good? Okay, let's go back and see how we have used it. So for now I'll just expand this. Okay, so here's the code. Everything else remains the same. We have a newed up a my customer object which we want to contain the desired result. We are again iterating to this customer, our original list, and this time we are calling this isOldEnough method on this customer class, and we are passing this age 30. If I go to this definition again, you can see that there is no method called isOldEnough, right? That isOld method enough is here inside this sum class. However, we are able to invoke this isOldEnough method on this customer class without any errors, right? And is supposed to return us true if this customer age is greater than 30. Okay, let's debug it and see if this actually works. So I'll just F10 and move ahead. So we are again iterating through this customer. Let's press F11 at this moment and let's see where it goes. Well, and it landed up in this method. which is an extension method for this class, which is now the correct understanding. So this customer is basically Mike 29 New York. So this is what first in the list, and we have passed age of 30, and it'll work fine, and it'll come back here. That customer is 29, so it won't add it. So we'll just press F10 and we'll keep going through the list. Okay, so now this my customer is having 2 customers in the list. I'll just put here so you can see it. Now you can see the 32 and 36. So John and Sachin, again only those 2 appeared in this list because their age is greater than 30. Let's validate this in our console output as well. Just using extension method, yeah, so this sounds good enough, right? Okay, so now we know how to write extension methods and how they work. So moving ahead, so this is where we now land up in the use of LINQ. Okay, so I'll just collapse this one so that it's less confusing to see. Okay, so this is the customer object, the original object which have 4 customers. Now when you add a reference to LINQ, so if you can see the unit they're using, you get some magical functionality on your collection objects. So this customer being a list of customers, so list of T has this method where, which can take a method which it will use to evaluate each customer in this list. Okay, we'll go over again. So this where is an extension method on list of T. So because this is list of customers, we already get this where method can be invoked on this object. Okay, and so this where method basically takes a function for this moment, for just for the sake of ease of understanding, let's call it a method. So it takes a method which it will execute for each customer in this list, and if this method returns true, it will add that customer object to your output. So if we just compare this with the earlier code we had, so here if you can see, what we are doing here is we are iterating through these customers, we are calling a method on this each object on this customer in the list, and if this returns true, we are adding this customer object to your return value. So in this case we are actually manually doing the addition to some other list of customers, but here it will return that list of customers back, because that's how this where method is written. And so that's all. So this code, this LINQ code, is equivalent to this code. Okay, let's do F10 and see what output did this gave us. And not surprisingly, the output is same again. Okay, so this where is basically an extension method, came as part of LINQ in C#, which is automatically added to all your generic collection types, or collection types should I say. Okay, so now this passing of this function name might sound a little odd to you, because this is not you will usually do if you have not came this far into C#, but that's possible. And this is basically, there are different types of just don't call it method, basically it's a new type which is func, came with C#, but that's a topic for another video. So we can pass a method which will be evaluated for each of these customers. Okay, let's go ahead and see the next. Okay, now this method is customer old enough was written over here, if you remember, right? What if this code is going to be used only once? And in that case, we don't really want to add a method to a class and have that code somewhere and someone coming there and modifying that. So it's best to use write this code inside over here, inside having a different function and giving this function name here. Why don't write the code inside that method over here? So that's you can do using anonymous methods. Again, anonymous methods are methods which can be declared inline, and so when you are passing it to delegate the where extension method, you have to create anonymous method like this. So the way you write it is you write delegate the input parameters. So in this case, customer is what we are operating on, the list of customers. So for each customer, get that reference to that customer and write a logic over here which will return a boolean value to the where method, right? So we are doing the same thing what we were doing here, but now we have an anonymous method which is just written inline. So whenever you are modifying this, you already know what you're doing with, what you're dealing with, right? So let's step through this and see what has come into output. Again, we have got the correct list, this time by passing function parameter to evaluate at runtime. Okay, so and just some brief about delegates. So delegates are you can think of them as function pointers. That's the term you will usually see in all the documentations if you have come from C background. Now the C# doesn't actually have pointers, but delegates are a type safe way of having a list of functions or list of methods which can be clubbed in a single invocation list, and if you invoke that delegate, it will invoke all the methods inside its invocation list. So in this case, basically we need only one method, but the way the where extension method works, we need to write an anonymous method to pass the logic to it. So this is how we'll do it. Okay, now post this delegate, we are going to see how we can use lambda expressions in place of these anonymous methods. So what are lambda expressions basically? Let's just go back for a quick theory bite. Okay, so as we just already saw, basically LINQ we have already used because when we use this where, it's part of LINQ functionality. Okay, so LINQ is basically a way in which you can query in-memory data. Okay, so it stands for language integrated query, and it's available in the .NET compliant languages such as C#. So whenever you pull data from external data sources, so LINQ usually works with other data providers through some ORM to achieve its best functionality through, for example, entity framework. And then when you have that data in your code, so you can query that data in simple C# language features through either through the extension methods we just saw, or there is another syntax which you will see in some time to query that data. Now the LINQ basically is dependent heavily on use of extension methods and lambda expressions. So the lambda expressions is the next we are going to see. Now lambda expressions is a way of writing anonymous methods in a very succinct and readable manner. So this is how we already written an anonymous method, if you remember, right? So instead of this, if we can just relate to these two syntaxes, we have one input parameter which is x, so which usually will be some object in the list on which you are operating, and you want to do something with that result. So this anonymous method is equivalent to this lambda expressions. The way you read it is x goes to x equal 10. So when you invoke this lambda expression on a where LINQ extension method, what it will do is it will pick each object x in the list and perform this logic on that object, and based on the conditions final result true or false, it will decide whether to add it to the final output. Okay, so let's just see the code actually. So if we just press F10 and move ahead. Okay, so this is how we can write the lambda expressions. So as you can see, instead of this we have this. So what we are doing is, after where we have written x goes to and the logic x dot age greater than 30. So this little code over here is equivalent to this anonymous method. Let's do F10 and see if this actually works again. And yes, it has. So you can see that using extension methods and lambda expressions we have got the same result set. Okay, so this list 4 is again containing your two customers, right? Okay, so this is about lambda expression. Now this is a very simple example basically, but it's good enough to get you started on using lambda expressions and experiment with them. And finally we have another way of achieving the same, is using a SQL-like syntax which is provided by LINQ. So this is how you write the code in LINQ. If you directly want to query that object, in our case list of customers, in a SQL-like syntax, the way you write it is from C in customers. So it will operate on each C in the customers, where C dot age greater than 30 and select C. So this is pretty much like SQL, except that this select, instead of being at the top, it becomes the part of expression at the bottommost position. If you can think of the flow, it sounds logical though. So what you're doing is iterating through this list of customers, applying a certain check, certain conditions, and based on this evaluation of this condition you are deciding whether this object in this list should be part of your output or not. Okay, so I'll just F10 through this one, and let's see what this list one has got. So using LINQ SQL syntax, again we got the correct results. Okay, so using all these 6 methods we got the same result, and they work similarly behind the scenes basically, but the way and the readability of your code increases tremendously. So I personally like the lambda expression syntax more than this one, but it's your choice of preference how you write it. The more and more complex expression you have to write, you'll find that the lambda expressions are a great way to simplify your code for various conditions you want to apply for. Okay, so then that's all we have for today, and we come to the end of this course. So we have covered different C# language syntaxes in this video. We covered the implicit type declaration, the object initializer syntax, extension methods, lambda expressions, and a bit starter of LINQ, which makes use of lambda expressions and extension methods, as well as the SQL-like syntax to operate on your list of or collection of objects in your memory. Okay, that's all I have for you tonight, and thank you for watching, and Let me know your feedback, your comments, and I'll try to improve on that, and also let me know what you want to see more on coming videos. Thank you for watching.